tree diagrams is what we're going to look at in this video. It's split into 4 parts. So first we're going to start off by looking at examples where a tree diagram has been drawn for us. We're then going to move on to looking at examples with pick and replace. We're then going to look at examples where a tree diagram has not been given. And finally, we're going to look at examples with no replacement, where something's been taken out and not been put back in. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. So with this first one, seems like I've already filled it in. So let me just rub that off. So if you read this question, we know the probability that he wins tennis is 0.7. So for tennis, the probability that he wins is 0.7. So the probability that he loses is going to be 0.3 because probability is out of 1. Okay. And the probability that he wins football is 0.5. So for football, the win is 0.5. So the loss is also going to be 0.5 because again, probability adds up to 1. Okay. So that's that done. So if you look at II, if I zoom in a little bit here, so it says work out the probability that Ben wins both. So he wins tennis and he wins football. So the way we do that is we look at this branch here, and looking at this branch, we are going to do 0.7 times 0.5. So then it says work out the probability that Ben does not win both games. So what it's saying is work out the probability that Ben does not win both games. Now that means he can either win one and lose one, or he can lose one and win one, or he can lose both. Okay, because it says he does not win both games. It does not say that he loses both games, so this is important to say here. If it said he loses both games, then you just do that. But because it says he does not win both games, that means he can win one and lose one and win one, or lose both. Now, the quicker way of doing this is either you find these three and add them together, or you can find the probability of what doesn't happen. What doesn't happen is this. Okay, he can't win both. So all we can do is we can do 1 minus 0.7 times 0.35. Sorry, times 0.5. And that gives me 0.65. So just to repeat myself there, what we did is we just found the probability of what can't happen. This can't happen. And we subtracted it from 1. Okay? The other way you could do this is you could do a win and a loss and a win, and a loss and a loss, and then add them three together. You will still get the same answer. Okay? So moving on. Work out the probability that Ben wins at least one game. Now, at least one game is important. What that word means is that he wins one and loses one, or he wins both, or he loses one and wins one. Now, you can find these three and then add them together, or the quicker way is what doesn't happen. The only branch here that doesn't happen is this branch right here at the bottom. So this branch is the only thing that doesn't happen. So what we take is we take what doesn't happen and subtract it from 1. This is the quicker way of doing this. So that would be 0.15 take away 1, which gives you 0.85. So hopefully you have pressed pause and had a go at the example on the right. So again, if I fill in the tree diagram quickly, we have hockey and basketball. So the probability that he wins hockey is 0.2. So the probability that he loses is going to be that. And with baseball, he wins is 0.1. So loses is going to be 0. that. So that's that done. And with II, work out the probability that Tim wins both. So that's saying essentially what's the probability of this happening. That's a win and a win. That's 0.2 times 0.9, which is 0.18. Work out the probability that Tim does not win both games. So the probability that he does not win both games is just going to be the 1 minus the probability that he does win both games. And that's going to be 1 minus 0.18. And again, just like I mentioned previously, the longer way of doing this is that he does not win both games, means that he wins one and loses one, or he loses one and wins one, or he loses both. You can find these three and then add them together. You will still get the same answer. And finally, wins at least one game. Remember the one word at least. One means he can win both. He can win one and lose one and win one. So the only thing here that doesn't happen is the fact that he loses both. That's the only thing that can't happen. So we do 1 minus what can't happen, and that will give us our answer. That is the quicker way of doing it. So if I do 1 minus 0.8 times 0.1, that gives me an answer of 0.92. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. Moving on. So here we have an example 2, but this time we can represent these as fractions rather than decimals. So again, if I zoom into the one on the left, we have 5 red counters and 2 blue counters. That means in total we have 7. So 5 out of 7 are red, 2 out of 7 are blue, and again the probability on the second pick does not change. So he picks out of this twice. So the first time he picks, and that's the second time he picks. So that's that done. Look at the probability that both counters are red. So that is this branch here. So that's 5 over 7 times 5 over 7, which is 25 over 49. Work out the probability that both counters are not red. So that's just going to be 1 minus the probability of them both being red. Okay? Because we've already calculated that, we can use that, so that'll be 24 over 49. Now, the long way of doing this, of not red, would be, well, you can have red and blue, you can have a blue and red, and you can have a blue and blue. You can find these three and add them together, and you will find you get the same answer, okay? And then we have Ivy, and for 4, it says, work out the probability that at least one counter is blue. So, at least one counter being blue means you can have a red and blue. That's, I was supposed to use my highlighter. You can have a red and blue, you can have a blue and blue, and you can have a blue and red. But what you can't have, the only thing you can't have, is a red and red. So what you can do is you can just do one takeaway, the probability of it being red and red, and the answer is 24 over 49. Okay, so hopefully you have pressed pause and had a quick example on the right. So just to fill this in, so that would be 5 out of 9, 4 out of 9, 5 out of 9, 4 out of 9, 5 out of 9, and 4 out of 9. So with II, work out the probability that both sweets are mint. So that would be mint and, no, sorry, down here, mint and mint, 4 over 9 and 4 over 9, which is 16 out of 81. Work out the probability that both sweets are not mint. So that's just going to be 1 minus the probability of them being mint. And work out the probability that at least one sweet is toffee. So at least one sweet is toffee means you can have a toffee and toffee, you can have a toffee and mint, or you can have a mint and toffee. Now the only thing that you can't have is mint and mint. So the quick way of doing this would just be 1 minus what can't happen. So that'll be 1 minus the probability that it's mint and mint, and that's 65 over 81. Okay, so here are some practice questions. Well, let's skip this one. Here are some practice questions. Press pause now and have a go. Here are the answers. Mark your work. And again, so I'm going to skip through this one as well. I don't think we need to look at this one. What I'll come on to is this one here with no replacement. So essentially what's different this time is that the bag has 5 red sweets and 3 blue sweets, but this time Ben picks a sweet at random and eats it. That is important, okay? The fact that it's eaten. So the second time he picks it, there's 1 less sweet, okay? And what I mean by that is, so in this case, we are going to have to draw the diagram itself as well. So we have the first pick, and he can pick out of red. I'll call this pick 1. He can pick out of red and blue, okay? So the first time he has 5 red, and 5 out of 8 red, and 3 out of 8 are blue, okay? So pick 2. So now the second time he picks, we have a red and a blue. And down here we have the same thing. We have a red and we have a blue. Okay, so given that he's already picked a red the first time, looking at this branch up here, that means he's eaten, and it says he's eaten it. So he's eaten the red, so that means there's 1 less red in here, and total out of a total of 7 sweets now. However, the blue doesn't change here. Okay, the blue is out of 7 because the first pick here is saying he chose red. So the one he ate is red. So there's 1 less red. But the number of blue don't change. But the total obviously is 1 less now. Now if I look at this branch down here, here he chose blue. So that means he ate 1 of these. So down here for blue, we now have 1 less blue. but the number of red on this branch stay the same. Okay, that is really, really important. And the rest of it works exactly the same now. So if I look at I, work out the probability that both sweets are red. So that's just going to be red and red. That's just 5 over 8 times 4 over 7. So that works exactly the same way as we've answered the previous few questions. So that's 5 over 14. And I, that would be, look at the probability that both sweets are the same color. So we can have a red and red, and we can have a blue and blue. So we know red and red is 5 over 14. We've already calculated that. Add that to blue and blue, which is 3 out of 18, sorry, 3 out of 8 times 2 out of 7. So we have 5 out of 14 plus 3 out of 8 times 2 over 7, which is 13 over 28. And moving on, look at the probability that both sweets are different colors. So we can just do 1 minus the previous answer, because the fact that they're different is just going to be 1 minus the probability of them being the same. Okay, so hopefully you've pressed pause and had a quick example on the right. So again, this time you're going to have to draw the branches yourself too. So we have pick 1 and we have pick 2. And again, if I zoom in here, we have chocolate biscuits and plain biscuits. So I'll use the word C for chocolate, P for plain. We have 7 chocolate, 7 out of 12 are chocolate, 5 out of 12 are plain. And if he picks a chocolate the first time, that means he's going to have 1 less chocolate. The number of plain ones stay the same. And if he picks a plain one the first time, that means he has 1 less plain, and the number of chocolate remain the same. So that is that done. Now it says work out the probability that both biscuits are chocolate. So that is just going to be chocolate and chocolate. So that's 7 out of 12 times 6 out of 11. That's 7 out of 22. Work out the probability that both biscuits are the same type. So that means we can have chocolate and chocolate, or we can have plain and plain. So we're just going to add chocolate and chocolate from the previous question to plain and plain. And if I do that, I get an answer of 31 out of 66. And looking at the last question, that they're both different types, so we can have chocolate and plain, and we can have plain and chocolate. And that would just be 1 minus the probability of them both being the same. So that would be 1 minus that, which gives you 35 over 66. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. And if you would like some more practice on this, I have got a full worksheet link down in the comments below. And if you found this video useful, I've got loads of other content like this on my channel. Do check it out.